we got to start the video. Okay, let me pause this. All right, welcome to 1.3. Let's chat with the ready first. Let's kick this off. We're using tables to find indicated values. This has us finding f of 5. This notation we've seen a little bit before. This is saying that there's some function f of n. Look at it. Here it is. And these are all the values that are a part of it. This is saying that it wants us to find f of 5, so where n is 5. So this is saying wherever n is 5, just tell me that outcome. Don't say that your answer is 5. Say that it's the outcome if n was 5. So your answer here is the number below, which is 12. Take a moment, pause the video, try to find f of 9. Hopefully you said 30 deuce. Let's go to C, find n that goes with f of n equals 22. So this has us working backwards a little bit. So we know that f of n equals 22. So we scan here until we see 22, deuce, deuce. The number above it is 7, siete. So our answer is 7. If we were speaking sign language, 7 would be this. So there you go. Take a moment, try part D. All right, so hopefully you said it was 2. I don't think this problem's too tough. Just use the table. Know that n is the top row, f of n is the bottom row. We'll see you on the next set of problems. Oh, I love these problems. For these problems, we're creating the missing equation for the sequence based on the table, the description, or the given equation. So we're giving a little bit of information and we're working backwards. Or just really talking more details about it. I don't think this is too tough. So let's dive in. We know in words that are recursive says that now equals the previous term plus 3. So sometimes this can be denoted as now is f of n, the previous term is f of n minus 1, and then plus 3. So what's happening here? This is jumping from 10 to 13 and from 13 to 16. What do you think that rate of change is? If you were a smooth operator, hopefully you said plus 3, which makes this 19. That helps fill in the table, but we're not done yet. We got a little bit more work to do. The explicit talks about how this is gonna be written actually using f of n and function notation, kind of similar to what I have up here, but really just focusing kind of on like y equals x plus 3, something like that. So you have some options with how you could express this. You could take note that this is the first term. So how does that change up the explicit equation? Because normally if we're starting with the 0 term, we could just use n as our variable. But since we're at term 1, we have to give respect to that and say that we're 1 away from where we normally start. So how does that change things? We have n minus 1 plopped in. We know that our rate of change is just by adding 3 over and over. So we can put 3 in here. But don't forget, this just talks about how it's going to continue moving. We have a value that we started with because it's term 1. So what was that value for term 1? Term uno. Think about it. Be a smooth operator and hopefully say 10. So that means that we're adding 10. So that's one way you could talk about it. However, there's another way we could talk about it if we went back to the 0 term. So let's imagine we backtrack 1 for the term. How does that change backtracking for the value? Normally we add 3 to the right. So we would deduct 3 here. So we would have a term of 7, value of 7. So no matter what, we have 7. And we still have n because we're talking about the term if we were working from the 0 term outwards. Notice if we work from the first term outwards, it's a little different, but we still give respect to the fact that our change is adding 3. So these are equal. 2 ways to talk about this pattern. There you go. Value of the 4th term. We already got that. That's 19. We did that right off the bat. We could say that these 2 equations are equal or explanation. So I think recursive is going to work the best personally. Why do you think recursive may work the best? How is that going to help us? Why was that the best thing to do if we were looking for the fourth term? The fourth term, what do you think? Well, we just keep adding 3. We know the previous leading up to it, so we just kept adding 3. So you could say something like that here. And I said that we keep on adding 3, no doubt, but we know the terms leading up to it. So we were looking for the fourth term. We knew the prerequisite term, so it's easier to just say, all right, just add 3 to that. No problem, no biggie. Let's look at 7. This is a little bit trickier, dealing with multiplication, but nothing we can't handle. Value of the second term is 24. It's not asking us here to make a table, but you're born ready. So let's just make a quick table. This is nothing. So on the second term, the outcome's 24. The sequence is being doubled at each step. So what does that mean? As we move to the next step, where we just add 1, so we're dealing now where n is 3, we could just double the previous amount, which was here. So if we take 24, multiply it by 2, that gets us 48, and we're feeling great. What are we being asked to find here? The recursive, so we need to have our starting point, maybe, and then how that concurrent equals the previous times 2. You can just say something like that. That works for me. The third term, we just got that. That was 48. Which of these do you think was helpful or better? Knowing that we had the second term and going to the third, or having this equation? What do you think was helpful? The recursive was helpful. And why is that? We were just finding the third term, and we need the second. Does that sound good? Okay. Let's keep this going. All right, so these are pretty simple. It's just asking us to evaluate the function when it's multiplying. Let's talk about these. So if we have f of 5, we know f of n is measured here. If we wanted to write the work for that, it could look something like this, with 5 as our exponent in place of n. Simple enough. We've seen this before. How we evaluate this can be a little tricky. So let me entertain this. I personally kind of imagine that 3 doesn't exist. 3 is just a figment of our imagination. And I evaluate 2 to the 5th. So take a moment. Find 2 to the 5th for me. Can you do that for me? Are you a smooth operator? That gets you 32. And now throw 3 back in. Why is this important? Based off of order of operations, we have to deal with exponents before we deal with multiplication, because 3 is in the front. So now we can just multiply this out. Multiply it out. 3 times 32 is 96. What a wonderful year. The Olympics were in Georgia that year. Fun fact. Take a moment, try 11. Try 11. Hopefully you said 12. Let's move on to the go. I don't want to spend too much time. Take a moment. 15 and 16 has us evaluating those inputs, getting an output. What's different between these two? If anything, what's different between these two? Hopefully you said that 16 smells funny and looks weird and has a flip phone. Nothing wrong with that. And also that it has parentheses. So how does that change everything? It means that if we were to evaluate 16, and we'll actually do this first. So if we were to take care of this, this means that when we start to plug in values, we got to give respect, no respect for the parentheses, but you got to give respect to it. -3 to the first power is just on its own. So that's just -3. And that's verbally how you should express this, is -3 to the first power. And we'll talk about how this is different in a second. But for now, take a note. This is -3 to the some power. Okay, capiche? Sound good? You're gonna give that respect to the parentheses or what? Let's move ahead. -3 now being squared. How can that be expanded? What do you think? Hopefully, you're rewriting it like so. -3 times -3. Negative times a negative's positive. +9, that is. And we'll even entertain if the input's 3. So -3 being taken to the third power, what we call cubed, 3 dimensions. If we expand this, boring to write out.
I kind of like drawing all this out. -3 times -3 times -3. That's not 5. -3. How does that change?
Well, this is still 27, but what kind of 27? What do you think? Hopefully you're saying -27. Take a moment, try to get the rest. See if you can do it. How does it change? What do you see a pattern with the numbers? I know I do. Hopefully you notice the pattern where it's negative, positive, negative, positive, negative switches off, making when n is, or the input's 4, this is positive 81. Finally, down here, 81 multiplying again with -3, 243. And again, it's negative. Huge deal. Capiche? So how does that differ from over here? This is subtracting 3 to some power. So notice. So that's different. That's not just taking -3 and multiplying it by itself over and over, because it's not in parentheses. You don't got to give respect to it. So I'm going to be doing something real crazy. I'm going to just make all of these negatives, because no matter what, I'm subtracting whatever it is, subtracting 3 to some power. I hope that's okay with you. We can actually just mimic all these numbers here and just keep them negative. The video is going to end shortly. I thought this was fun. I hope you had a good time. Please make sure that you're making a set of comments about the video. That's going to come up shortly, so you can get that 5 out of 5 for this side quest. Thank you so much for your time. I hope you took notes on this. I'm going to check them. Thanks. You're the best. Keep rocking in the free world.